Hello, this is the introductory learning unit of the educational module Architectural Design and Applications in IoT, which sheds light onto the key aspects of the IoT architecture, emphasizing on cloud computing. There are multiple technology options for deploying a server-side infrastructure. The first option is obtaining a physical server. A physical server, also known as a bare metal server or dedicated server, is a single-tenant computer server, meaning that a specific physical server is designated to a single user. The resources and components of a physical server are not shared between multiple users. Each physical server includes memory, processor, network connection, hard drive, and an operating system for running programs and applications. A bare metal server is large in size due to the powerful processing components that it contains. At this point, it might be appropriate to mention the benefits of virtualization, which can be exploited in server-side computing. Virtualization is the act of creating a virtual rather than physical version of something, including virtual computer hardware platforms, storage devices, and computer network resources. Virtualization operates in a multi-tenant environment, allowing running multiple virtual machines on the same physical machine at the same time, which share the physical resources of the physical machine. Virtual machines users do not have access to OS and data of other virtual machines running on the same physical machine. In a virtual environment, the resources of the virtual machine can be changed at any time in order to meet a user needs. Another option for deploying a server-side infrastructure is obtaining a virtual machine. The architecture of a virtual machine is a little more complex than that of a physical server. Thus, a hypervisor, such as VMware vSphere or Microsoft Hyper-V, is installed on top of physical hardware. There are two types of hypervisors. Type 1 hypervisor, also known as a bare metal hypervisor, runs directly on the system hardware. Type 2 hypervisor runs on a host operating system and provides virtualization services, such as input/output device support and memory management. A hypervisor is then used to create and manage virtual machines, which have their own virtual computing resources. After that, you can load multiple guest operating systems and server applications on top of the virtual machine. Thus, virtual machines allow you to run several operating systems and applications on the basis of the shared physical hardware, which makes it a more cost-effective option than a physical server. Another option for deploying a server-side infrastructure are containers. A container is a standard unit of software that packages up code and all its dependencies so the application runs quickly and reliably from one computing environment to another. A container can run on top of physical server or a virtual machine and their corresponding host operating system. Containers and virtual machines have similar resource isolation and allocation benefits, but function differently because containers virtualize the operating system instead of hardware. Containers are more portable and efficient. Multiple containers can run on the same machine and share the operating system kernel with other containers, each running as isolated processes in user space. Containers take up less space than virtual machines. Container images are typically tens of megabytes in size and take just seconds to start, can handle more applications and require fewer virtual machine and operating systems. On the other hand, each virtual machine includes a full copy of an operating system, the application, necessary binaries, and libraries, taking up tens of gigabytes. Virtual machines can also be slow to boot. Multiple virtual machines can run on a single machine in the presence of a hypervisor. Both containers and virtual machines have benefits and drawbacks, and the ultimate decision will depend on your specific needs, but there are some general rules of thumb. Virtual machines are a better choice for running apps that require all of the operating system's resources and functionality when you need to run multiple applications on servers or have a wide variety of operating systems to manage. Containers are a better choice when your biggest priority is maximizing the number of applications running on a minimal number of servers. Docker is currently the most popular container platform. Docker features the Docker engine, which is a runtime and allows you to build and run containers, and includes Docker Hub, a service for storing and sharing container images. While Docker provides an open standard for packaging and distributing containerized applications, some questions need to be answered. How would all these containers be coordinated and scheduled? How do all the different containers in your application communicate with each other? How can container instances be scaled? These can be done through a so-called orchestration platform. Container orchestration manages the life cycles of containers, since they are frequently launched and shut down more often than virtual machines. Orchestration does, but is not limited to, provisioning and deployment of containers, availability and failover, scaling up or removing containers, moving containers to a new host should there be a crash or heavy load, and other resource allocation. The first to market was Docker, with the Swarm platform for container management. There are also Apache Foundation's Mesos and Marathon, which are a bit more complex than Swarm. The gold standard for container orchestration is Google's Kubernetes, which is open source, but it is also provided by major cloud providers as a service. Cloud computing is the provision of shared resources as, for example, hardware, data, and applications as a service over a public or a private network. More specifically, cloud computing provides as a service the products of virtualization, on demand, either to the users of a public network, i.e. the Internet, or to the users of a private network owned by a company. Customers are adopting cloud-based infrastructures because of the rich data-oriented services such as data ingestion, data transformation, advanced data storage, data processing, data analysis using machine learning, and artificial intelligence algorithms, and integration with a large variety third-party SQL and NoSQL databases. Virtual machines could be thought of as a foundational service offered in the cloud. In short, one can provision a virtual machine with specified operating system, resources like RAM, CPU, and storage, and use it to run any software. They typically don't include any extra features outside of basic auto-scaling, so installing, running, and making an application accessible will not take much time and effort. The basic advantages of using cloud computing service is the pay-as-go charging nature, which takes into account the number of virtual machines used, as well as on the amount of resources are utilized without upfront or termination costs. In addition, usually there are significant discounts for bulk usage. Also, it is most likely to have an option to pick where, geographically in the world, the virtual machine is deployed. This could help enable faster response times to customers in certain areas or redundancy if a data center experiences downtime.